Welcome back, fellow cloud enthusiasts. Are you ready to unlock the secrets of reducing your cloud costs without compromising on performance? Well, you're in the right place. In today's video, we'll dive deep into the world of cloud rate optimization, where we'll explore game-changing strategies to help you slash your expenses and maximize efficiencies. The agenda for today is I'll cover why we start here. Why is cloud rate optimization our first stop on the road to saving money in our cloud if you're breaking into FinOps? Second, I'll go give an overview of the commitment tools that are available. So what are the instruments that you can leverage in the various cloud providers to save you money and reduce your rate? And thirdly, I'm going to go through an analogy to try and explain those commitment tools and how they all hang together. So without further ado, I'll jump right in if this will work. So we start here with rate optimization because it's fully controlled. Generally, the central FinOps team manage the commitments for the organization. So no matter how many engineering teams or how many business units you have, it makes one of the tenets of FinOps, which we covered in one of the earlier episodes, was about its centrally managed element of FinOps is this rate optimization. FinOps will look at the environment and the cloud environment and your infrastructure footprint overall, and will make commitments based on that overall environment. The reason for that is the more of the environment you're looking at, the better discounts you can get because you're not making a silo decision in isolation based on the workloads running for one application in one business unit. You're looking at all the applications across all the business units, across all the regions, and you're making a holistic decision to drive the maximum return on your investment. So the fact that it's fully controlled within finance, there's no need for engineering to take any action. Granted, the commitments that are made, you may need engineering input before making some of these commitments, but it's you don't want it to be a case of the tail wagging the dog. So the engineers will build and run what they need to build and run in the best way possible, and then FinOps layers a commitment strategy on top of that to get the maximum return on the investment. But you don't need to, engineers don't need to do any re-architecture, refactoring, anything like that to allow you to make these commitments because it's a billing construct that sits outside of the workflows and workloads. There is no direct engineering impact. We do need their input on what they're doing, but we do not need them to take any specific action for us to make these commitments. The second reason is it's low-hanging fruit. So if I'm starting a new FinOps role and this company has never heard of FinOps before, the first way that you prove your worth is you buy a savings plan, for example. You look at your usage and you see that on average we use $50 an hour of compute. So I will buy a $20 an hour savings plan, which will save about, depending on your workloads and your machines, about 30 to 40% if it's a 1 year. So I'm saving 30 to 40% on that portion of my workload straight away with a click of a button. And that's what AWS push as well. They want you to buy these savings plans and push that easy button. In a further episode, I'll go through reasons why that's not always the right thing to do, but as a starting point to get some savings on the board and to get buy-in from your stakeholders, it's a really good way to get started. Real low-hanging fruit there at the crawl stage of FinOps. There's low barriers to entry. So as I mentioned, you don't need any engineering effort to implement these. All you need is your permissions to be set up within the environment to allow you purchase reserved instances or savings plans or CUDs, whatever that instrument might be. The fact that there is that low barrier to entry means that you can get started pretty much straight away. Like I say, if I was starting in FinOps, that's the first thing I would do. I get my permission set up. I'd have a look at the environment, look at the historic trends, and see what base layer commitments I could buy now to get the clock ticking, because it's like the compound effect. The sooner you start with these commitments, the sooner you start to see the savings. And you can build on those over time as your information gets better, as your understanding of the business gets better, as you've got tighter links with engineering, and you can adapt and mold your commitments better to fit what engineer is doing to get better rates. But as a starting point, this is where you want to go. And also one other thing is it doesn't require any deep technical knowledge. So you can just look at the numbers, like all us accountants like to do, and say, if my number is $10 an hour, I can buy $2 an hour. It's easy to understand, whereas usage optimization is a whole different ballgame. If you're looking at unattached EBS volumes or idle VMs, right sizing some of your EC2 or your RDS instances, that's a whole different ball game and different gravy, and that's where you need to be hand in glove with engineering. But that's more on the walk and run phase of your FinOps journey. So that's 100% why we start here with rate optimization, to get something on the board. So what are the tools that we leverage? First off is an EDP, which stands for Enterprise Discount Program. That's what AWS call it. Sometimes it's called a PPA, Private Purchase Agreement, and it could be called any number of things for different cloud providers. But effectively what it is, it's a billing construct. What that means is that you get your bill from your cloud provider, and this discount is applied across that bill. So if you've got a bill for 100 grand, and you've got a 20% EDP, 20% is lobbed off that bill. It covers all the services that are included there. How an EDP is got is you have a negotiation with the cloud provider, and that might be on a yearly basis, it might be over a number of years. And what you do is you commit to spending a certain amount with that cloud provider. For example, with AWS, you might say, for the next 1 year, I'm going to spend $2 million on AWS. And then they'll come back and say, okay, we will give you an EDP, which is a blanket discount of a certain percentage. That percentage will be based off a number of factors, such as what is your spend? So how much are you committing to spend with them? How much are you committing to spend versus what you're spending with them already, if anything? What the term is as well. So you'll get a much better rate on a 3-year commitment than a 1-year commitment. Also, if you go 10 years, you get a better commitment rate as well. But like anything, the further out that you're trying to predict into the future, the harder it is to get that number right. When gauging that commitment number, and I will go into this in more detail in a future episode, you're trying to get as close to that commit number as you can without going massively over it or massively under it. So for example, if you commit to spend $1 million for a year, and then the cloud provider gives you a 20% discount. Say for example, it comes to the end of the year and you've actually spent 2 million. Well, you've hit your commit, so you don't owe the cloud provider anything. But if you'd committed up front to spend $2 million, you might have got 25 or 30% discount. So you've kind of left money on the table there. The flip side of the coin is that if you get to the end of the year and you spend $500,000 and you've committed to spend $1 million, you have to cut a check for that difference. And there is ways that you can try and reduce that gap, and which again I'll cover in future episodes. But that's why the EDP and the commit, you'd be working closely with the procurement or sourcing organization, because that's a big feature of what they do. So you'd have to work hand in glove with them to get that right. Next up, you have savings plans, and I kind of alluded to those earlier. These are general purpose savings vehicles that will flow to a type of usage. So for example, the AWS Compute Savings Plan is probably the most common one. That's where you commit to spend a certain number of dollars per hour on the compute service. So the savings plan will flow to cover any workloads that you have that are in EC2, EKS, Lambda, and some of the other container services. Savings plan don't really care what the machine type is, what the region is, anything like that. You've no parameters. As long as it's within compute, that savings plan, that $5 will flow to cover that and apply the discount there. So it's the most general purpose discount that you can get. Other than EDP, it kind of flows and has maximum flexibility. You also have savings plans with Azure, which work in a similar way. Then you have reserved instances, or RIs is what you might hear them commonly referred to, or reserved VM instances is what they call them in Azure, or committed use discounts if you're in Google Cloud World. What these are, it's another savings instrument, but it's more specific. So what I mean by that is if you're making a reserved instance, you pick the machine that you want to cover, you pick the region, and you pick the platform and the tenancy. So for example, you might want to cover an M5 large Linux in North Virginia that is shared tenancy. That those would be the five parameters that you would specify in your reservation. And that would mean that as long as you have usage within your entire environment for that workload or that instance, that specific instance, the discount will be applied there. If your usage for that workload goes away, then that reserved instance goes to waste. So it means that you're not only paying for the engineering team might have done a great job and reduced their footprint and not run that machine anymore. They don't need it anymore, but you're still paying for that reservation. So it's not tied to the machine. It's an independent instrument that that moves differently. So it is more restrictive than the savings plan. And then the reserved instance works similar across the different cloud providers. So so it's less flexible than the savings plan, but you get a better savings rate with it, and there is some other benefits, which again I'll go into in a future episode. Finally, then we have spot instances. So these are instances where, for a temporary period of time, for whatever reason, an instance may become available. And what that means is that the engineering team can configure their applications in such a way that they buy these spot instances to for temporary workloads that they might have. So if they have development or test workloads, maybe something like a spot instance might be something that they get to cover that. It's not in production, so it's not customer facing or critical to the business, but by using a spot instance, you get the best discount rates. It could be 70, 80%. It depends on the region and the machine type and all that stuff, but it gives you the greatest discount rate. So as I'm kind of going down the list here, you're getting kind of different discount rates and better discount rates, but again, you're being more specific. So the reserved instance is specific to a machine. The spot instance is a machine, but for a specific period of time. Now we've covered a lot there, and how I find it helps sink in my brain is by if I learn something by way of analogy. So in this analogy, we're thinking about a gym, and this is the best pixelated Google image of a gym reception I could get. So blanket discount in the analogy of this new gym world would be if you're an old age pensioner or a student, or you're in the UK if you're an NHS worker, you will your membership will be at a different rate to other people, and that's just applied across the board. You haven't committed to anything, you haven't signed up to anything. It's just because of some underlying factor, you have that blanket discount. That's the same with the EDP. It's an underlying prerequisite that applies to your AWS or your cloud bill. The next piece then within the gym is you have annual membership. So you could just pay as you go. So every time you go to the gym, you pay at reception, but that's expensive. The equivalent to that is a cloud on demand bill. So you just pay as you use it. Again, the blanket discount applies. So if you're an OAP and you pay as you go, it's cheaper. Or if you're a student and you pay as you go, it's cheaper. Um, but it is still more expensive than getting an annual membership. So an annual membership is like a savings plan. You've committed for a period of time, you've shelled out the cash, or else you've committed to shell out the cash on a monthly basis or whatever it is, but you get it at a cheaper rate than pay as you go. So your annual membership is your savings plan. In this fictional gym world analogy, your next piece would be if the facility could be split. So you go into the gym and you say, love the gym, big fan, but I only want to use the swimming pool, or I only want to use the free weights section or the cardio section. That they'll give you a cheaper rate for that. It'll be cheaper than your membership because you're only using part of the gym. In our cloud world of rate optimization, that's like a reserved instance. So you're being more specific about what you're using. Finally, moving on to the spot element of it. So you want to use only the swimming pool, but you're kind of not pushed about when you use it. You're going to use it off peak. So they'll say, okay, we'll give you a better rate for using the pool off peak because it's better to have somebody in the pool and us getting some money than having the pool empty and no one using it and us getting no cash for it. So I hope this analogy kind of makes sense of how those different commitment mechanisms make sense. So that's cloud rate optimization. So this is where the money is. This is the low hanging fruit. If you're getting started in FinOps, this is your first port of call. Optimize that rate to start driving savings. We covered the fact that it's where we start, the easiest piece, went through the high level view of the commitments that are in place, and also that gem analogy to try and drive home the lessons that are there. Next up, what I'm going to do is I'm going to dive deeper into cloud specific commitment tools. So I'm going to dive into AWS at the highest level. Then I'm going to go into the savings plans, RIs, Spot, all those different instruments. And that video, hopefully, depending on how I work out this stuff should appear down here somewhere. That's it. That's all I had for now. Thank you so much.